Welcome to Mini Lecture 2 for Unit 10. In this mini lecture, we are going to talk about the properties of relatively nearby galaxies. And by relatively, I mean maybe 1 billion light years. Sounds like a lot, but if we work it out, it's things in the nearby universe, things that probably have not changed very much. So in this mini lecture, we're focusing on two sections of Chapter 24, Sections 1 and 2. First, I'll begin with a little history lesson, just sort of to color in how we came to understand galaxies as we do today. And then we'll go through the different types of galaxies and definitions of groups and clusters of galaxies. So our story of galaxies begins with Charles Messier, who we've talked about a little bit in terms of like the Crab Nebula and so forth. Messier was a French comet hunter, and that's really, he was born in 1730, not 1830. And he made a catalog of things in the sky that were fuzzy, like comets should be, but were not comets in that they didn't move across the sky. He had well over 100 objects in his catalog. Some were later realized to be star clusters, but many persisted in being sort of cloudy in shape, and so these became known as nebulae, because the Latin word for cloud is nebula. In the late 1800s, most of these nebulae were still not understood, but large telescopes and better optics had discovered that a good fraction of these nebulae had spiral shapes. So below is a picture of what we now would call the Whirlpool Galaxy. At the time it was the Whirlpool Nebula. On the left is a drawing from the mid-1800s, and on the right is a picture taken in the very early 1900s. So you could see that astronomers at the time could see the shapes of these, but they still really had no clue what these objects were. So by 1920, astronomers had compiled a list of facts about the spiral nebulae. The largest and brightest spiral nebulae had some stars visible, but the rest just looked very cloud-like. So some of the largest and brightest would be things like the Andromeda Nebula. Their spectra of the spiral nebulae were mostly absorption line spectra, like you would get from stars, but they also had emission lines on top of that. So that told us there was something hot and dense with a cooler gas in front of it, but also some energized gas there as well. The majority of the spiral nebulae had Doppler shifts that showed they were moving away from the Sun. And the spiral nebulae were not seen in the Milky Way, in the band of the Milky Way, only outside of it, away from this band. So in 1920, two famous astronomers of the day, Harlow Shapley, who we talked about in the last mini lecture, he was the one who determined the shape of the Milky Way using globular clusters, and Heber Curtis, who was at Lick Observatory. They had a debate over what the nature of these spiral nebulae were. Harlow Shapley thought that the spiral nebulae were clouds of gas that were forming new stars and belonged to our own universe. Now, he used universe in a different way than we use it today. Basically, when Shapley says universe, he means galaxy. What we would call a galaxy, a collection of stars and gas all bound together by gravity. Shapley thought that all the spiral nebulae were part of our galaxy, part of the Milky Way. Heber Curtis considered these things to be island universes. In other words, each of these spiral nebulae were like our Milky Way, a separate collection of clouds and gas and stars separated from the Milky Way by vast distances in space. So let's see why they thought this. So Shapley believed that the Milky Way was the entire universe and the spiral nebulae were part of it. Shapley thought this mainly because he had calculated the size of the Milky Way as being about 100,000 light years across, which is really close to the number we use today, and also at the time it was considered stunningly huge. There was nothing known to be that large. I mean, the most distant stars that had been known before Shapley went and worked on it were, maybe 1,000 light years away. this is 100 times larger than that. And so Shapley just couldn't imagine that the universe would be larger than this. Secondly, Shapley had a friend named Van Manen. Van Manen studied the spiral nebulae, and he claimed to see one spin over time. Not fast, but just change very slightly over a decade or so. And if these spiral nebulae were really far away, like Curtis claimed they were, then the rotation would be faster than the speed of light, which we knew was not possible. So basically, Shapley said, based on this, they have to be part of our own galaxy to explain both of these observations. Heber Curtis believed that the spiral nebulae were these island universes, and he argued that this based on a couple of points. One, the spectra of the spiral nebulae showed mixtures of absorption line spectra, like we see from stars, and emission line spectra, like we see from clouds of gas. And so he thought, well, these must be mixed collections of stars and gas. And he was absolutely right there. Second, he noticed that many of these spiral nebulae had what he called obscuring bands or dark lines across the middle. And he thought if the Milky Way were also a spiral nebula, and it had one of these bands around them, that would explain why we don't see the spiral nebulae in what we now know as the disk of our galaxy, because our view would be blocked. He didn't know what these obscuring bands were. Today we know that they're dust. But he was right that that effect, that blocking of the light, explains why we don't see spiral nebulae in the disk of our galaxy. Now, Curtis also had a couple of things that he had completely wrong. He didn't believe Shapley's size of the Milky Way, so he thought that the distances were not very big and that the Milky Way was much smaller than Shapley thought it was. And he thought we were near the center of the Milky Way, which was also completely wrong, and he used that in some of his arguments. So neither Shapley nor Curtis were completely right. But who was right? Well, we know, but at the time nobody knew. And it took a gentleman you may have heard of by the name of Edwin Hubble. Here he is, a picture of him at the telescope on the left. This is a staged photograph. You can tell that because, first of all, Hubble rarely looked through the telescope like shown here. He took photographs using photographic plates. Second, you would not be allowed to smoke a pipe at the telescope if the mirror was exposed to the sky, because you wouldn't want smoke getting on it. And third, the lights are on, and so he wouldn't be able to see anything. Hubble studied nearby galaxies, these spiral nebulae, and he discovered Cepheid stars in the Andromeda Nebula, which was the largest of the spiral nebulae. And he used the Leavitt law to determine the distances to these Cepheid variable stars, and he found that the Andromeda Nebula was several 100,000 light years away, well outside even Shapley's Milky Way, and just a huge absolute scale that we're talking about. Millions of light years was something that had not been considered at the time that the universe could be that large. On the right here we have a plot, one of his plots of a Cepheid in the Andromeda galaxy, or the Andromeda Nebula as it was known at the time. You see that it had a period of 31 days, so we know the period. So you can figure out what its absolute magnitude is, you know how bright it appears, and that allows you to get the distance, which in this case he got 220,000 parsecs, which is actually not quite far enough. That's about 750,000 light years, and we now know the Andromeda Galaxy is about twice as far away. So we now know that Shapley was right about the size of the Milky Way and the structure of the Milky Way, but Heber Curtis was right that the spiral nebulae were island universes, that when we look out and we see the Andromeda Galaxy, or we see other spiral nebulae, that they are very much like our own Milky Way, consisting of their own stars and gas and dust, orbiting around some center of gravity, and separated from other galaxies by almost unimaginably large distances. So here's a picture taken by the Hubble Space Telescope. It is looking at part of the Andromeda Galaxy. And most of the stars you see, most of the dots you see in this picture, are stars in the Andromeda Galaxy, 2 million light years away from us. That globular cluster on the far right is a globular cluster in the Andromeda Galaxy, and because we're looking in the outer parts of Andromeda where there's not much dust, we can even see through and see background galaxies. A lot of the faint fuzzy things you can see over at the left. There's another spiral galaxy. Each of these are separated by huge space. We are looking across vast stretches of time and space when we're looking at other galaxies.